So last time we were working on this tree node class, we really kind of got it in a good space here. But let me just double check to make sure what I have matches what you have. I put in some comments, but what's key to this thing is the tree node is generic data type, so it's a generic. But the tree node extends, this is by the way what I was just talking about with the grade 11s. So it uses inheritance to extend something called comparable. Comparable is an abstract class. Remember, abstract classes mean they are classes that cannot be instantiated. Which means, since you can't create an instance of the class, you can only use it for inheritance. Okay? But as well, this is not just an abstract class, but it's an abstract interface. And an interface is an abstract class, but the interface means that it cannot be instantiated and it has empty methods. Right? So within the interface it has these empty methods that have no content, but those empty methods must, and that's the enforcement, must be overridden. So you must override the methods within the interface of the abstract class comparable. So what that does is it forces our class called tree node class to override the compare to method, because that's the method we're looking for. It's all based on the fact that we want compare to has to be a method within this class. Well, specifically, it has to be a method within the class data that the tree node uses. So whatever data we give this node, it has to have a compare to method within it. That's enforced by the abstract comparable interface. Yes? Well, because it's not the tree node class that's extending it. It's the data type T that's extending it, right? It's tricky. Like if these brackets weren't there, then you're right. Then that's what it would implement it. That's right. Okay, but again, none of that's in the IB content, so you don't got to worry about it. Okay, so then we had a constructor, the tree node constructor. We had another couple constructors. We used some fancy this keywords so that it shortened up our code. And the last method that we needed was the insert method. Now it's the insert method that uses compare to, right there. So that's where it became crucial, that whatever the data we were comparing had built into it a compare to method to allow us to check the things that are less than or greater than or equal to. That was crucial because based on that comparison, less than or greater than, we can insert the data to either the left or the right of wherever we are. So whatever node we're at, I either insert to the left or insert to the right. And this is also done recursively. Recursive call there and recursive call there from the left side or from the right side. Okay, we'll come back to this method because this is actually the key to the logic of the binary tree here, is that that is occurring. Okay, does everybody got all that? All right, so now we're going to add a Java class called the tree class. Okay, so this will be our tree. And it's going to go into the collections package. All right. Okay, so the tree class. Well, for the tree class to work on the tree node, it's going to need to do the same extension of comparable. So I'm just going to steal that piece of code right there and put it in the tree class as well, because it will also use generics. So the tree also extends comparable. Well, specifically, the thing that tree uses extends comparable, okay? Because it uses a tree node. So there's a private tree node of data type T. But with the tree object, it only needs one entry point. Now, if this was a linked list, we would use a node called front and a node called back if we wanted a good doubly linked list. We don't need that. We could have just had one entry point. But a tree really only does have one entry point, and it's called the root. So we enter the tree from the root. Okay, so that's easy. Let's write our constructor. Public tree, the root equals null. That was easy enough. Now, in order for the tree to work, we've got to put stuff into the tree. We've got to insert into the tree. So we're also going to need to write a public void insert tData method. Oops. So how do we insert data? This is actually very simple at this level now. There are two scenarios for inserting data. The first scenario is, what if it's an empty tree? Well, how would I know that? How would I know the tree's empty? Yeah, so if the root equals null, then the root equals a new tree node with the data in it. So that's how I insert it if it's an empty tree. The root just becomes a brand new tree node. Otherwise, else, it's very simple. I just go to the root and I insert the data. And it's done recursively at that point. And that's it. That's all I need to do to insert a piece of data into this tree. Okay, let me try to diagram this for you. Well, hang on. Let's put it to the test. Let's go to wherever our main is. I'm not sure, it's our main class is out there somewhere. Okay, and here in main, let's make a tree. A tree equals a new tree. Now, what data type should we use? Let's use integer. Wow. So a tree of integers equals a new tree of integers. Integer. Now, import from the collections package. Be careful. There is a tree package that you can import from a weird place though. sun.reflect.generics.tree. That's even beyond java.utility. That's a different spot. But anyways, we're going to create a tree and then tree.inserts. I don't know. Let's insert 50. And then we'll insert two more. Inserts 30 and 90. So think about what that's going to do. It's going to insert the first node 50, and then a 30, which is less than 50, and then a 90, which is greater than 50. That's what the tree should look like if our code operates properly. Okay? And then let's say I did it one more time with a 40. So we'll insert those four nodes and a 40. Now, we did this before. You guys kind of got this. The way 40 goes is it's less than 50, but greater than 30. So 40 should go right here. 40 should be off of the the right side of the left node of the root. Woo! Woo! Okay. Let's see how this goes, starting with the constructor. The constructor of our tree class just basically says, okay, just set this thing called root to null. Okay, I gotcha. So right here on that line, it just makes something called root. It's a reference to what will be a tree node, but right now it's just set to null. There's no tree node there. But then we call the insert method of the tree class. Okay, so let's take a look at what that looks like. Come on, there we go. So according to the insert method, it says, well, if the root is null, oh, root is null, then the root now points to a brand new tree node, okay, and it takes the data with it. So it's taking that 50 with it. So now we go to the tree node class, and we look for the constructor that matches this. Okay, well, I need a constructor with just data. Okay, so here it is. So the 50 gets passed right here into data. So there's the 50. It then takes that data along with it up to here, and it says this dot data equals data. So the 50 is assigned, and left and right are both set to nulls. Okay, so that seems simple enough. So back here, the root now has a 50 in it. That's the root. And this is null, and this is null. No problem. Now it calls insert on 30. So we go back to the tree class. We go back to insert if root is null. Root is not null anymore. So it drops here. It says root.insert. So now it's calling the insert method of the tree node class. So I better take a look at what that says. So according to the insert method of the tree node class, I've now been passed a 30 right here. And it says, if the data, 30, compares to this data, 50, is less than 0. Well, it is. 30 is less than 50. Then it says, if this, that's the root, dot left is null, oh, it is null. Perfect. Then the left equals a brand new tree node with the data, 30 in it, and according to its constructor, these two will be set to null. Done. It's done here, it's done the insert there, goes back to tree, it's done the insert there, goes back to the main class. And now we call insert 90. Now I'm not going to go through the code for you, but it would then create that, because it would eventually get to the same spot. It would get all the way over to the tree node class, and it would get down to here, and it would compare, and it would be greater, and the right would be null. But now it would call the 40, okay? So 40 is now being passed into first the tree class. So the tree class gets a 40 right here. The root's not null, so it's calling a 40 off this root. Right, so now the insert method is here with a 40 in it, not a 30 anymore. Okay? So it compares 40 to 50. Well, 40 is less than 50. So now it drops down to here. If the left is null, it's not null. The left of 50 is not a null. So it now drops to this else statement. If this dot, so what it does is it now calls this dot left dot insert. So it's calling an insert now off of the left of the root. Well, this is the left of the root. And it's calling insert off of this. So now insert is called recursively with the 40, and it compares 40 to 30. So it drops down to here, it's greater, and the right of that is null, so that's where it builds it right there. And it puts the 40 there. So it's using recursion to the advantage of the tree structure to really be efficient in the way it works. Okay? I hope that explanation made sense. So that's insert. Sweet. Okay? But now, what the heck are we going to do with this tree? We can put stuff in it, but for example, how do we turn the tree into a string? Public string to string. What do I return here? How do I turn the entire tree into a string? How do I output a tree? Any ideas? Look, let me build up a little tree here for you guys. Actually, hang on, maybe I have one. Let's see. We have some ones that we were working on. Previous class. There's this one, I think. Yeah, this is a good one right here. Here's a good tree. This is a nice binary tree. If I told you to print this for me, what order would the numbers come out? Like, how would you do that? Would it start at 82? Would it start down here? I mean, you know that this is the order that you got them, but let's say you didn't know that. Say it came in a random thing. How would you output this? The answer to that question is not as simple as you think. There are several different ways we could output it. Okay? We could output it, for example, by level. Right? There are 4 levels to this, right? So maybe the outputs would go 82. Then for the next level, for this level, there's 2 nodes. So do I go this one, then this one? Maybe 7, 104. But there's nothing saying it couldn't go the other way. It couldn't go 104, 7. For this one, there's 2, but there could be as many as 4 on that row. There could be even more on this row. So is that the way I output it? Or do I start at the bottom and work my way up? So there's several different ways you can output a tree. So I'm going to present some of them to you. The 3 classic ways we go through a tree, and by the way, I'm not going to use the word go through. I'm going to use the word traverse because it's more commonly used. To traverse just means to travel or to walk across. And I'm going to present 3 of them, 3 tree traversals. The in-order traversal, the pre-order traversal, and the post-order traversal. And I'll leave you today with this question. Where have you seen those 3 words before? Anywhere? Infix, prefix, and postfix. That's right. In a lot of ways, they relate to that. It was one of the reasons why I brought it up as well. I knew it was going to come back in trees. So tomorrow, we'll take a look at those. And guess what? The code is short, very short code, but it's recursive. So it's kind of tricky. But we will look at that tomorrow. Have a good day, everybody.